All right, so we've got, in addition to what we talked about yesterday with making sure that we can still figure out things from the unit circle, we also want to be able to, I guess it's going to be more of one more type of problem where we find trig values for things that aren't necessarily on the unit circle, but it has to do with the same kind of concept, finding trig values based off of a coordinate and a terminal on the terminal side of the angle. So it's going to be similar to what we did yesterday, but not quite. So with that, let's go ahead and grab notes if we haven't already. Okay, so 4.3. Trig and unit circle, part 2. Okay, so this other kind of problem that we get, we're going to call them coordinate problems. Okay, coordinate problems. So they're going to take the format of this sort. We're going to say given -4, 3 as a point on the terminal side of an angle theta. Find the exact values of the 6 trig functions. Okay, so this is the sort of problem that we're going to see. And when we see a problem like this, what we're going to start with is kind of drawing a picture of what is going on. So the coordinate -4, 3 is in the second quadrant. And so we're going to just draw really quick a coordinate plane. And really, we need to only highlight the second quadrant here. -4, 3, so 1, 2, 3, 4, 1, 2, 3. That's where our coordinate is located, and it's on the terminal side of an angle. And if I could draw straighter lines, that would be great. But anyway, so that's kind of a picture of what's going on. This angle theta is from the positive x-axis, going in a counterclockwise direction. And we want to find the values of the 6 trig functions, but this one is not on the unit circle. So sine is x and cosine is y kind of goes out the window for the moment. But what we can do is use right triangle trig. Because if you take a look at this kind of picture going on here, we can just drop a line down to the x-axis, and all of a sudden we have a right triangle where we know 2 of the side lengths. I know this side length, I'm going to call it -4. I know we can't have negative lengths technically, but to get the correct sine, cosine, tangent values with the correct signs and everything like that, you're going to want to leave whatever sign is involved in the coordinate in the problem. And then this one is 3 for that length there. So we're like 95% of the way to being able to find our trig functions. This is going to be our reference angle theta that we're going to use. This is the angle we're going to be looking at. So this is considered the reference angle. So anyway, This is the angle that we're going to use. Even though this is technically the angle that we're given, this angle is going to reference the same location for us. Okay, so then the last thing that we need to do before we can just go write all of our trig functions and everything is figure out what the length of the hypotenuse is. What is this distance here? So step one is going to be kind of to do the Pythagorean theorem real quick. Or I mean, draw the picture first. Second step, Pythagorean theorem. So we can go 3 squared plus negative 4 squared equals c squared. Or if you've already recognized this as a 3, 4, 5 triangle, awesome. Then if it's one that you recognize, go ahead and use whatever Pythagorean triples you know. But if you don't recognize it, no big deal. You'll still get the same answer this way. So you get 9 plus 16 equals c squared. So c is 5. So that means that this side right here is 5. So then kind of our third step here, six trig functions. So we need sine, cosine, tangent, cosecant, secant, cotangent. Okay. So this is where we need to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, all that good stuff that we talked about at the very beginning of last week when we were doing just basic right triangle trig, because that's what we're taking it back to now. So sine would then be 3 over 5, since this is the opposite, adjacent, and hypotenuse. So cosecant would be the flipped over version, 5/3. And then cosine, adjacent over hypotenuse, so negative 4/5. This is where the negative becomes important. Leaving that in there with our coordinate. Remember, that came from our coordinate back up here at the beginning of the statement of the problem. So then secant, you flip that and you get negative 5/4. And then tangent, opposite over adjacent, so negative 3/4. And cotangent, you flip that and get negative 4/3. And that would be our answer. So that's really all we're doing on these. Draw the picture, find the hypotenuse with the Pythagorean theorem, and then find your six trig functions using right triangle side ratios. Okay. Any questions from that one? Any numbers we're not sure where they came from or anything like that? Okay. If it's in a different quadrant, a lot of times what confuses people is how to draw the triangle and not having a great picture for what's going on. So here's what it's going to look like in other quadrants. Okay, so in the first quadrant, this might be your coordinate. This is where we drop the line to the x-axis. You're always dropping a line to the x-axis. A lot of times people are weirdly tempted to drop a line over to the y-axis. Don't do it. Drop a line to the x-axis. In fact, we're going to write that down. Okay. The second quadrant is like the case that we just did up here. The third quadrant if your coordinate's down here somewhere, here's your right angle for your triangle. There's your theta. And then lastly, the fourth quadrant. Your point's down here somewhere. Dropping it to the x-axis again, and then here's your theta. Okay. Also, some things to keep in mind. In the first quadrant, both values are positive. In the third quadrant, both values are negative. And in the fourth quadrant, we have the x being positive and the y being negative. So just things to keep in mind. As we go through this, making sure that we've got the correct positives and negatives given the quadrant that we are in. Okay. So that's what it's going to look like in other quadrants. Let's do some more of these. This time we're going to be given 4, -7. We're going to find 6 trig functions. All right, so 4, -7 this time. So we're going over 4, down 7. That's going to put us in the fourth quadrant. So that's going to be this kind of a picture that we have going on here. So first thing, draw your picture. We're going over 1, 2, 3, 4, going down 1, 2, 3, 4, 5, 6, 7. Puts us way the heck down there. Okay, so when we draw our triangle then, again, we're dropping the line to the x-axis. That's where we're going to put our right angle. Here's theta. Then we have to label the sides. We know this one is 4 units long and this one is -7. Okay. So now we've got just about everything that we need to have labeled. Now we got to do the step 2, which is Pythagorean Theorem. So 4 squared plus -7 squared. 4 squared is 16. 7 squared is 49. Together that makes 65. So our missing side is the square root of 65. So we can put that in our drawing too. Okay. So now the interesting thing becomes, since I'm leaving this in exact terms and we want everything to be in exact terms, anytime I get a root 65 in the denominator, we're going to have to rationalize that. So we'll talk about how that works as well. But let's get started with, we want sine, cosine, tangent. Let's start with those 3. So we know sine is opposite over hypotenuse. So the opposite If you want to go ahead and label your sides, you can as opposite, adjacent, and hypotenuse, just so that you don't get them turned around. But we're going to get -7 over root 65. But that leaves us with a square root in the denominator, and we don't want that. So instead, we're going to multiply on the top and the bottom by root 65, because that will get rid of the square root on the bottom. So that gives us -7 root 65 over 65 for our final answer. Okay, and as this becomes easier and something we're more accustomed to doing, it's something that you can kind of do from the outset. We know that cosine is going to be 4 over root 65, so instead, I would just write it as 4 root 65 over 65. And then tangent, opposite over adjacent, so -7/4. And then secant, cosecant, and cotangent, we don't have that same problem with because the hypotenuse is on the top for those. So we're going to do cosecant theta, secant theta, cotangent theta. So cosecant would just be root 65 over -7. Secant would then just be root 65 over 4. And cotangent would be -4/7. Okay, so that's another one. Any questions from that one? Any numbers we're not sure where they came from? Any steps we want to go back to? Okay, give everyone a moment to finish writing, and then we're going to have one for you guys to try. We'll kind of go from there. Why is it root 65 and not 65 squared? Good question. So when we do the Pythagorean theorem, remember it's a squared plus b squared equals c squared. Do you mean like how did we get root 65 in the first place, or why is it when we multiply that it's not 65 squared? Okay, yeah. So when we do the Pythagorean theorem, it's a squared plus b squared equals c squared. So here's the first side squared, the second side squared, and it's equal to the third side squared. So really what we have here is that c squared is equal to 65. So then to get c by itself, we have to take the square root of both sides, because then that'll cancel and we get c is the square root of 65. Yeah, no problem. Kind of like in the one up above where we got 25 was equal to c squared, so then we took the square root of both sides to get 5 equals c. Good question. Yeah, I kind of skipped that step there. Any others? All right, let's have you guys try one. This time we'll do given the terminal side goes through the point -5, -12. Find the 6 trig functions. So draw the picture, do the Pythagorean theorem, find the 6 trig functions. When you think you have them all, type "got it" in the chat, and then we'll talk about them. All right, we got one. All right, for your picture, this is what we should have gotten when we're drawing the picture. So if you did it this way, you're on the right track. Should have gotten 13 for that hypotenuse. -5 squared plus -12 squared is 169. All right, I'll give you another minute to find your trig functions, and then we'll put those up too. All right, and on these ones, making sure that we keep track of the sign is important as well. Not sign, but like the sign positive or negative, making sure that we keep the -5 and the -12 in there, but the 13 will end up being positive. So we're going to leave this as a positive value and these two as negative values. So for sine and cosine and secant and cosecant, we end up with negative things. And for tangent and for cotangent, we end up being positive because the negatives will cancel each other out there. Just kind of like it does on the unit circle as well. You'll see something similar based off of the quadrants. All right, here we go. For sine of theta, what do we get? -12/13. Yes. Looks like we agree there. -12/13. Awesome. So then cosecant, you just flip it. -13/12. How about cosine? -5/13. Awesome. And then for secant, you flip it. -13/5. How about tangent? All right, -12/5. So we have -12 over -5, right? So when we get something like that, yeah, with -12 over -5, we can just cancel the negatives because a negative divided by a negative is a positive and get just +12/5. And then for cotangent, we can flip it and get 5/12. So that's the only one that we have to be a little bit careful on here, making sure that when we keep our positives and negatives straight, and that when we have a negative over a negative, that we simplify it and make it a positive. So that's really the thing you have to be careful of, mainly in the third quadrant. The other quadrants don't tend to have that issue. It's really a third quadrant thing because a lot of things are negative there. Okay. So that's really the main kind of new problem that we have for today. The rest of it is going to be more practice on our assignment with finding exact values of trig from the unit circle itself. So pulling it directly from the unit circle. So you should have still your unit circle from your notes yesterday. If you don't, make sure you write it down. It's a good thing to have or print it out. But anyway, we want to make sure we're working on becoming more and more familiar with the unit circle as well, especially that first quadrant of it. Okay. Otherwise, the rest of what we're going to do is mainly going to be homework kind of stuff. So let's take a look at the assignment. Today's assignment is going to be on a worksheet. And again, when you turn in worksheets and stuff like that, make sure that you attach the work. That you attach either pictures or a PDF or of some kind of your assignment. So here we go. Today's assignment, the first bit of this page is all an example and stuff like that. So if you would like to see another example of the kind of problem that we just did, here's another great example. And then it's got 3 problems for you to do on this first page that look just like that kind of problem that we've been working on today. The second page, there's a bulk of it is example. And then you've got 4 problems where you're finding the exact value of the expression using the unit circle. When you get an angle like -60 or something like that, you don't have -60 in your unit circle, but we do know about coterminal angles. So remember, you can find a coterminal angle by adding 360 to it. That does fall within your unit circle. So on a few of these, like that one, that's what you're going to have to do before you can look at the unit circle and find that angle. So you'll have 4 like that there, and then you've got some more just like it. You've got 6 that are like that first kind, and then you have 6 more down here that are like that second kind. Okay, so that's your assignment for today. At this point, feel free to stick around if you have questions or if you want to work out a specific problem with me, or if you want to work on a particular type with me, you can. Otherwise, I will see you all tomorrow.